Okay, so this is a Unit 1, Day 7. This is the last day of the unit, and we're going to wrap up the three variable systems. And now we got applications, which just means that we have word problems. So our learning target is that we could solve a word problem in three variables. So for this one, I'm going to focus more on the setting up part and not so much on the solving part, because we've been solving for a couple of days, and if you need more practice on that, go back and work on that first. Make sure you can solve before you jump into this unit or into this day. But so if we're setting them up, I mean, first off, and this is good even for any sort of standardized test you might have. Sometimes you are graded on whether or not you label things. So it says Monica has $1, $5, and $10 bills in her wallet. They're worth $96. If she had one more $1 bill, she would have just as many $1 bills as $5 and $10 bills, and she has a total of 23 bills. So how many of each denomination does she have? You could guess and check all day with this. You might eventually figure it out, but it'd take a very long time, so I wouldn't go that route. If we made up some systems of equations and solved, we could have this done in a couple of minutes. Okay, so first off, let's label what we're going to call everything. So if I'm going to use x, y, and z, then x is going to represent the number of $1 bills, y would be the number of $5 bills, and then z would be the number of $10 bills. Okay, so just keep that in mind as we go here. Now it says that the worth is $96. Well, that's where we got to write it with worth then. So the number of $1 bills times 1 plus the number of $5 bills times 5, because we're worth $5 each, plus the number of $10 bills times 10 would equal $96. So the next one then, if she had one more $1 bill, so if I had the number of $1 bills plus 1, then she would have just as many as $5 and $10 bills, so y and z together. And then the third one, she has a total of 23 bills. This one has nothing to do with value. So just the number of $1 bills plus the number of $5 bills plus the number of $10 bills, that equals 23. So, and I think that's maybe the hardest thing between the first and the last one. We multiply by 5 because they have a value, $96. Here, there's no value. They're just bills. So the number of bills plus the number of bills plus the number of bills equals 23. Now, if you want, like I said, I'm going to focus on just setting them up. This one you could solve for x and substitute. You could bring it over to the left side and you could do some elimination. Totally up to you. But the answer in the end, if you choose to solve it, would be 11 $1 bills, 7 $5 bills, and 5 $10 bills. Okay? And on the homework, you will have to solve it. I'm just saying, maybe save your time for solving on the homework, but the setting up part's kind of the new thing here. We want to make sure we know what to do. Okay, so the sum of three numbers is -2, so we're talking about numbers, three numbers, and we could just think of x is the first number, y is the second number, and z is the third number. Okay, so the sum of the three numbers, so it's x plus y plus z equals -2. The sum of 3 times the first number, so 3 times the first number plus, because that's sum, twice the second number, and the third is 9. And then the difference between the second number and half the third number, so the difference between these is subtracting the second number and half the third number is 10. So there's your system all set up. And if you do want to solve it, the answer is 3, 5, and -10. Okay, a change machine contains nickels, dimes, and quarters. There's 75 quarters in the machine. That has nothing to do with value. And the value of the coins is 725. That does have to do with value. So you got two equations right there you could write. So if you want to, you could even do N, D, and Q instead of X, Y, and Z on this one. It really doesn't matter how you do it. It's up to you. But there's 75 coins, the number of nickels plus the number of quarters plus the number of dimes is 75 coins. Then it talks about the value being $7.25. So now I got to put a value on them. So a nickel, I take the number of nickels times 0.05, because that's what they're worth. I'm not sure why I put quarters and dimes in that order for it. Dimes are worth 0.1, and then quarters are worth 0.25. Okay, so all have to do with value. There are 5 times as many nickels as dimes. So right now, nickels is winning. There's 5 times as many nickels as dimes. So if I want to make them equal, I'm going to take the number of dimes times 5, and that would equal the number of nickels. So be careful with that. A lot of people will say 5 times as many nickels. They'll put 5n equals d. If you multiply the number of nickels times 5, now you got way more nickels than dimes. You originally just had 5 times as many. Now you have 25 times as many. So don't do that. You have to quintuple the number of dimes to make it equal the number of nickels. Okay, now if you do that work, then again, this would be a good one for substitution because you have n by itself, plug them in, and you do all your solving, and you'd get 50 nickels, 10 dimes, and 15 quarters. Backside, last week Regal Cinemas, they sold a total of 8,500 movie tickets. Proceeds totaled 64,600. So there's 2 things right there. Here's an equation, and here's an equation. I'm just not quite sure what my variables are. Whoops. So I have a value and I have a total number. Now I see that the tickets were sold in one of 3 ways. There's matinee, there's student, and then there's regular. So I'll just use M, S, and then R. So if there's 8,500 tickets, M plus S plus R equals 8,500. But now if there's this much money, I'm going to put the value with them. So a matinee ticket is $5, so the number of matinee tickets times 5. The number of student tickets is times 6. And then the regular admission is $850. And that added all up would be $64,600. And then the last thing is, the last part was if twice as many student tickets are sold as matinee. So right now, twice as many students, I mean students are winning, so I need to double the number of matinee to make it equal. Okay, so and substitute, I got S by itself here, but in the end, my answer is 900, 1,800, and 5,800. For a party, you're cooking a large amount of stew, because who doesn't have stew at their parties? So we need to buy some meat, potatoes, and carrots. Now, the meat costs $6 a pound, the potatoes cost $3 a pound, and the carrots cost $1 a pound. So what I'm going to find is how many pounds of each ingredient. So they take the number of pounds of meat times 6, plus the number of pounds of potatoes times 3, plus the number of pounds of carrots times 1, and that equals $48.50. Now, if I get 13.5 pounds of food, that means M plus P plus C equals 13.5. So you're at pounds a pound, so it doesn't matter what it's not worth anymore. A pound of meat is equal to a pound of potatoes if we're just talking about weight. Now you buy twice as many carrots as potatoes. So right now carrots is winning. So in order to even it up, I got to double the number of potatoes to make it fair or make it equal. Okay, so a whole lot of these good for substitution problems. And if you plug it all in and solve it, you get 6 pounds of meat, 2.5 pounds of potatoes, and 5 pounds of carrots. Okay, last question. The sum of 3 numbers is 16. Now, in here we've got a larger number and a smaller number. We want to kind of put them in order. So we could just say X, Y, Z, X being the smallest, Y being the middle number, and then Z being the largest number. So the sum is 16. So X plus Y plus Z equals 16. The largest number, Z, is equal to, so Z equals the sum of the other 2, so X plus Y, and then and 3 times the smallest number, so 3 times X, is 1 more than the largest. So if I took 1 away from it, it'd be equal to the largest, equal to Z. So there's my 3 equations, And you can do some substitution here. I mean, if these equals Z, you can set them equal here. Solve for X, work your way back, find Z, and then plug them all in. But you'd get the smallest number is 3, the medium number is 5, and then the largest number is 8 on that one. And on all of these two, you can always, maybe not on the homework you wouldn't, but on a quiz or a test, plug them back in. See, do they add up to 16? Is the largest number equal to the sum of the other two? So does 8 equal 3 plus 5? Yeah. Is 3 times the smallest? So 3 times that would be 9. Is that 1 more than the largest? Yeah, 9 is 1 more than 8. So you could check pretty quick to see if you got them right just by plugging everything back in.